Welcome learners. Today we will see how to simulate maximum power transfer theorem using PSpice software. For that we need to open PSpice software. So click on Capture CIS, create a new file, new project, maximum power transfer theorem, and then click on OK, and then create blank project. So once if you create blank project, then you need to add the elements. Here there are two ways to do maximum power transfer theorem. One is by taking the Thevenin's equivalent circuit, and another one is by taking the original circuit itself. So here now we'll see how to implement maximum power transfer theorem in using Thevenin's equivalent circuit. So for that I need to add a source, a DC voltage source, and that I need to search for VDC and then click on OK. I am placing the DC voltage source. Then after that I need to add resistances. So for that I need to go for analog. Under analog you have resistance. Click on resistance. Now I need to have two resistances. One will act as Thevenin's equivalent resistance and another one will act as load resistance. Now we need to connect the two elements using the wire. And then you need to connect the ground. After connecting the ground, you need to give the values for this elements. For VDC, as of now I am taking it as 50 volts, and then the equivalent, so this resistance I am changing it as RTH. RTH is nothing but Thevenin's equivalent resistance. So once if you do the circuit analysis and then convert the given circuit into Thevenin's equivalent circuit, you will get the value of RTH. So as of now I am taking it as 56 ohms is the equivalent resistance after finding out the equivalent resistance I got. Now in order to use this load resistance, I am changing R2 to RL, so which is my load resistor. Now I need to vary this load resistance from 0 to certain value greater than RTH, such that I need to observe what is the power dissipation in the circuit and how is the power in the resistance. So for that I am taking the RL value as a global parameter. Why? Because I need to change the value of RL from 0 to a certain value. For that, first I need to create a variable RL, and flower brackets is used for creating a variable. And then now I need to assign this variable. Uh, so for this, first I'll change this R load and then RL. I need to go for a parameter that is available directly. You can say PARAM search. Then it will search the library. So okay. So this is the parameter where you can obtain in special libraries. Under special libraries you have parameters. So click on OK and place these parameters in your window. And then now I need to declare this variable RL. So what is the value? So here we double click the parameters and you need to add new column. So what is the variable you want to declare as a global parameter, and its value is 100 ohms. So it is a dummy value. We can take any value. Click on apply and then click on close. So now if you observe here, we have the value of RL is in parameters, which makes it visible to the global simulation. Now after this I need to go for simulation settings, new simulation profile, and then under new simulation profile, create new simulation profile. So in order to analyze the value of power with respect to resistance, I need to go for sweep analysis. So what is the importance of sweep analysis? Nothing but you can vary the parameter from certain range, and you can observe the current and voltage and power readings in that. So for that, first I need to check the analysis type as DC sweep. In that I need to have global parameter. So I need to select global parameter, and then what is the parameter that we have seen, that is RL we have considered, and you need to have the resistance from which value, this global parameter RL, from which value to which value I need to change. So here I can change it as with an increment of 0.1, 0.1, and then click on apply, and then click on OK. So what it do is nothing but now the value of RL is changing from 0 to 100 ohms, and 0 to 100, or depending upon the value, uh, and then it observes the different, what is the variations of current, power, and voltage in the circuit. So for that, after simulation profile, now I need to run the program. After running the program, you will get a blank waveform window. So already if you observe here, the scale on x-axis has been changed from 0 to 100. Now I need to check for what is the power dissipated in the load resistor, WR. So if I click on W means the power watts for R load. If you click on OK, then you'll observe this value. Now you need to know at what value the maximum has been attained. I need to click on toggle cursor. If I click on toggle cursor, so these parameters will get enabled. Now in this particular waveform, I need to identify the peak point. So for that I will go for cursor peak. So if you observe this cursor peak, uh, then it will get a line here, and then click on this mark label, then it will show. So where the maximum power has been obtained. So it is at 56 ohms and the power is 11.161 watts. So this is how you need to apply maximum power transfer theorem using Thevenin's equivalent circuit. Thevenin's equivalent circuit. Now we can do the same using uh, normal circuit. So instead of using this Thevenin's equivalent circuit, you can use normal as normal circuit, and you can directly find without going with RTH and VTH. So for that, I am going to do the new simulation. So file, new project, maximum power transfer theorem, and then create a blank project. Then here you will get a blank project. Under this you need to connect the circuit diagram. Now instead of going for Thevenin's equivalent circuit, I'll directly connect the circuit itself, and I'll observe what is the maximum power transfer theorem, or under what circumstances you'll get the power maximum. So let us start with this simulation. First I need to go for DC source, VDC, and then click on OK. Now I am designing the circuit. So I have 6 resistances, let us assume. So I need to have 6 resistances for in the circuit. I need to go for analog and then resistance. Click on OK. So first resistance, second, third, and then fourth, fifth, sixth resistance. So this are the 6 resistances in my circuit, where R4 is my load resistor. I am assuming the fourth resistance as for load resistor, and then so this is my circuit. Now I need to connect the circuit using wire. So then first I'll connect the circuit. So this is the circuit what I have considered. Now I need to place the ground terminal. Click on OK. So this is the ground terminal, and then now I need to change the values. So the voltage I'll take it as 100 volts, and then resistances. So it is 500 ohms, 800 ohms, 600 ohms, 1200 ohms, and then this will take it as 850 ohms, and then R load. So here I need to consider, so what is the condition at which maximum power is transferred to the load. I need to click the load resistance as a global variable. So for that I'll use flower brackets to define the global variable. So RL. Now once after defining the load resistance, I need to add the value of this load resistance using parameter. So you need to go for special. Under special library you can search for param. Here you will get parameter, and then click on OK. I am placing this parameter. So here R load is equal to RL. Now I am defining this RL as a global variable in this parameter. Now I need to add new column. In this I need to place the global variable and its value. Click on apply and then close. Now, sorry. Now we need to minimize or close this window. So this is the simulation of the circuit. So we have connected the simulation circuit. So this is the circuit what we have considered. Now I need to go for simulation profile. PSpice new simulation profile. So create a new simulation profile. So under this I need to go for DC sweep analysis, and then I need to select what is the global variable I have declared RL, and its value is 0.1 to a maximum of 1000 or 2000, and then increment of 0.1. Click on apply, click on OK. Why I have taken 2000? For that I need to find the equivalent resistance. So theoretically you need to verify this. So that first I need to know what is the equivalent resistance I got. Based on the equivalent resistance, then I'll keep the value of the uh, simulation DC sweep simulation time as well as the value of parameter. Here if you observe here, in order to find Thevenin's equivalent or equivalent resistance, I need to remove the load resistor and short the voltage source. If I short the voltage source, uh, 500 R1 resistor and R6 resistors are in parallel, so I'll get 500 into 800 divided by 500 plus 800, 1300. So now this is in series with 600, and then this is in parallel with 1200. So therefore 907.6 into 1200 into 1200 divided by 906 plus 1200, 2100. So divided by 2107. So I get 516. So 516 plus 850. So that is 1366. So approximately I'll get the equivalent resistance as 1366. So that's why I have simulated the PSpice simulation from 0.1 to 2000 such that I can observe the maximum power. So now I need to run the program, and then once if you get the output window, you need to check for which resistance we have considered, R load. So I am mainly focused on power, so I need not to bother about what is the current and voltage. So I'll calculate the power. So this is the power, and if I check what value I'll get the power, I need to go for cursor, toggle cursor and peak value, and then label that value. So almost all at 1366 you'll get the value, and the maximum power is 224.535 milliwatts. And apply maximum power transfer theorem using PSpice software. Thank you.